Hi, my name is Lucian Todose and I am Senior Engineer at RKB Bearing Industries. Today's seminar was entitled Internal Geometry Optimization of Rolling Bearings via a New Two-Phase Evolutionary Algorithm. Optimization. Optimization is probably one of the most important concepts in today's science and engineering. Finding any solution to a problem is not nearly as good as finding the one optimal solution to the problem. Optimal design, what does it mean? The ever-growing complexity of design problems obviously requires appropriate technique and instruments. The actual tendency in technical design of products is optimal design. That means conceiving and solving a mathematical programming problem based on the mathematical model of a real engineering problem. In mathematics, mathematical programming refers to choosing the best element from some set of available alternatives. Often, this number of possible alternatives is infinite, or at least very large in computational time terms. It's worth noting here that the term mathematical programming is not directly related to the computer programming. The structure of a mathematical programming program starts with the establishment of a so-called design variable vector. All the components of the variable vector are decision variable, and each of them has to lie in a certain range, continuously or a discrete one. Then, we have to consider also an objective function and a set of constraints. Solving this mathematical programming problem means to find the vector x so that the objective function reaches its global minimum or maximum and the constraints are all satisfied. After a rigorous study of the requirements for the specific product, a set of independent parameters that fully and uniquely define the product can be identified. That will be types, geometrical dimension, materials, and so on. All these parameters are in fact the unknown of the design problem and also of the optimization program. The optimization program will consist of one or more objective functions that have to be either maximized or minimized and a set of constraints. At this point, two issues have to be solved. The first one, how many objective functions should be used? This first issue is closely connected to the specific optimal design problem. It's up to the designer to choose the appropriate approach. The second one is which are the instruments or algorithms that should be used to solve the optimal design problem. RKB thinks that evolutionary algorithms are the answer to this question. An evolutionary algorithm is a subset of evolutionary computation, a generic population-based meta-heuristic optimization algorithm. An evolutionary algorithm uses some mechanism inspired by biological evolution, reproduction, mutation, recombination, natural selection, survival of the fittest, and so on. Each optimization parameter, xy, is encoded to a gene using a binary or a real code. These genes, in fact, the parameters x1 until xn, form a chromosome, or sometimes called an individual, which describes a unique design solution. A set of chromosomes forms a population among which the best individuals are selected for reproduction. Recombination is made using a specialized operator, and from the combination of genes of the parents we get the offsprings. The offspring mutated or not, are inserted into the population, and the described procedure begins again and again, creating in this way an artificial Darwinian environment. Here you have a scheme of a very simple evolutionary algorithm. The algorithm starts with an initial population random created, then the individuals are evaluated according to their objective function, and the population is ranked next according to the assignation of a fitness. In the ranked population, the individuals authorized to be parents were selected, and they form the so-called intermediary population. On this intermediate population will action the recombination and mutation operators, and it issue the offspring assembly. These offsprings will replace totally or partially the parents, and so the loop is closed and it can begin once again. Why evolutionary algorithms? I prefer here to quote Peter J. Bentley, who in his excellent book, Evolutionary Design by Computers, find at least 4 main reasons why the choice of evolutionary algorithms is appropriate for design problems. The first is that evolution is good, general purpose problem solver. The second stipulates that uniquely evolutionary algorithms have been used successfully in every type of engineering design. Evolutionary and the human design process share many similar characteristics. In 1991, David Goldberg, this guru of genetic algorithm, compares the recombination of genetic material from parent solution when forming a new child solution with a human designer combining ideas from 2 solutions to form a new one. And finally, the most successful and remarkable designs known to mankind were created by natural evolution. As an example, I intend to present here the optimization of the internal geometry of a roller bearing. In fact, it is about the NP1092 bearing. That is a cylindrical roller bearing with a 1/12 taper bore. The main dimensions of this bearing are the bore diameter, the outer diameter, the width of the bearing. Obviously, as one can see, it's a bearing with one single row of rollers, and the contact angles, it's nil. A very important element of a bearing is the roller, and here we have a sketch of a roller in which we present the total length of the roller, the effective length of the roller, and the radius of the chamfer. RKB propose this value for the radius of the chamfer according to diverse value of the diameter of the roller. Another important value is the thickness of the cage tenon existing between 2 neighbor rollers. This value, this thickness, depend on the number of rollers, the effective diameter of the roller, and the pitch diameter of the bearing. We find an exact formula for calculate this thickness, and approximative one with very good results. In the optimization that follow, we used the exact formula. Here we have 2, probably the most important parameter of a bearing, the static radial load rating and the dynamic load rating. In the optimization, first of all, we studied the geometry of the bearing and we identified 4 genes that are enough to describe fully and uniquely the design of the roller, of the bearing. These genes, in fact, this variable, were the roller diameter, the roller length, the pitch diameter of the bearing, and the number of rollers. Here you have the range in which we can find a solution. The objective function was the basic dynamic radial load rating. Obviously, we intend to maximize this parameter. In order to perform the optimization, 5 constraints were identified. The first one is connected to the thickness of the outer ring that must be greater than a minimum value. This value was set up at 26 millimeters according to our knowledge and experience. The second constraints were connected to the thickness of the inner ring, and this thickness should be greater than a minimum value, always set it at 28 millimeters. The next 2 constraints are connected to the circumferential distance between the rollers that have to lie in the range of 23 to 25 of the roller diameter. And finally, the thickness of the shoulder has to be greater than 15 millimeters. Solving the programming problem, means to use some specialized software, and in order to solve the above optimization program, we use Cambrian software that is a very new software based on a new 2-phase evolutionary algorithm. After optimization, the following values for the genes were obtained. The diameter of the roller was found about 56 millimeters. The length of the roller was found at 69 millimeters. The diameter, the pitch diameter was 572 millimeters, and the number of roller was 26. The value of the objective function, that means the dynamic load rating of the bearing, was 261 kilonewton. That means a very, very high value, a very large value. For these values, we obtain even a large value for the static load rating, about 3,700 kilonewton. Here you have presented the mainframe of Cambrian optimization platform, and in the next slide you see the results tab of Cambrian, and here, border in red, you find the best solution of the optimization program. Here it's the final population of the evolutionary algorithm. Conclusion. We have shown that using the most modern, precise, and sophisticated method in designing bearings, it is possible to find optimal solutions that correspond to remarkably large dynamic and static radial load ratings. In the future, the bearing internal geometry could be improved and the value of the basic radial dynamic load rating could be increased if the constraints will be adapted to the new situation based on the gained experience and the technological advances reached both in material properties and machining technology. Thank you very much for your attention.